Hi, everyone. I can't believe I'm following Oliver's talk. Oliver's talk was so good. Lower your expectations. It's not accumulating here. So yeah, hi, my name's Ashley. Rob mentioned a few things about me earlier. I am a software engineer here. I work in this office, and I work in the JavaScript Infrastructure and Tooling team. Whoop, whoop. Yeah. And yeah, I'm also one of Bloomberg's delegates to TC39. So live and breathe JavaScript. Very typical story arc we will go over. There'll be a problem, there'll be one solution, and then dramatic reveal, and then the interesting bits, and wrap up. So I'm going to be talking about faster builds. Specifically, I'm talking about developer builds. So as opposed to maybe your production builds. So when you're deploying code out to your customers, you're probably going to want to, or be happy to, let the build be a bit slower if it's going to get you better output. It's worth the trade-off. And you're not doing that constantly. You're just doing this when you do a release. Maybe you're not doing it. Your CI, Jenkins does it for us. I'm talking about developer builds where you have the opposite kind of set of trade-offs. You actually want the build to be as quick as possible, and you don't particularly care if your JavaScript coming out is a little bit slower, because you're probably running it on like all local stuff, probably no I/O, like powerful laptop. And what you're really wanting is like fast developer feedback. The thing you want is to know if the code you wrote does what you wanted it to do as quick as possible. The thing about fast feedback loop is you get that with TypeScript. Like as you're typing, you're literally getting feedback about if I do dot on this thing, what properties does TypeScript think I can access? Or if I do the wrong thing, I get feedback saying that's wrong, you're trying to add numbers to strings. But then that's that tension of, because you're using TypeScript, you now have that build step you need to go through, which can be slow. So ideally, we want fast developer feedback in the editor and also running the code. Everyone here knows what TypeScript is, I would imagine. But just to set up an example, we have some TypeScript at the top. And in this pre-Porffor world, we can't execute that. Engines like V8, you have to give them just the JavaScript. The thing above might as well be CoffeeScript. It's just full of syntax errors. The way we were compiling TypeScript at one of our internal build tools, we were just using the TypeScript library to do this. One, because this tool's been around for a long time, and there was a time before Babel and SWC where the only way you could transpile TypeScript was with TypeScript. And they have a public API. If you import TypeScript as a library, there's a bunch of things you can just use. One of them is transpile module. So this isn't type checking. It's just you put a string in, you give it like your tsconfig data, and then you get a string back out. Just to help explain the other things, we'll go through like what's happening under the hood. But I'm going to whiz through this super quick because I don't have enough time. If you do want to know exactly more about this stuff, I would really recommend Author the Rox's talk. It's on YouTube. It's like 45 plus minutes. It's called something like How the TypeScript Compiler Compiles. And he goes through all of this in detail and way better than I could. So quick whizzing through it. The scanner. So if you have your string coming in, a string is a list of characters. The scanner is then kind of chunking that up and now giving you a list of tokens. You can think of these like words and punctuation. Then the parser gives you now the tree format, because everything just being a flat list doesn't really help because code is nested in nature. The binder is a thing that does a whole bunch of stuff, but it's all about adding extra layers of metadata about how these nodes relate to each other, which you need for later parts. It's also used by the type checker. You then have N transforms, where it takes the syntax tree and then it creates a slightly different tree, and then it takes that tree and creates another tree. And then finally, you then have the emitter or the printer, which then takes that tree and flattens it back into a string. If you ever want to see some of these things, online playgrounds these days are so good. So Auto added a bunch of plugins to the TypeScript playground. There's a plugin that lets you kind of see the rough output of the scanner. There's the TypeScript AST viewer that shows you the syntax tree and some of the binding information. Going back to the TypeScript playground, there's another plugin from Auto that lets you see all the transforms your code goes through. So an example here of a transform, if you have this modern syntax, this is the Elvis operator, I think. That short thing, if you want to take that modern JavaScript, but take it back through the levels down to 2018, it ends up being this long thing. So that's what the transform is doing. Online playgrounds are amazing. One of the key things here, because of the transformers, the code is moving around. What you put in doesn't line up with what you get out. And that is particularly true for TypeScript. So here, if I put in here like class, this with some field, why is it not updating? Oh, any ideas? Let's maybe turn this off. I think it's, there was a breaking change in 5.6 API and some of the TypeScript Playground plugins broke. Let's do ES next. This is annoying. When does the TypeScript Playground ever break? It breaks when you're trying to do a demo. That's when it... Oh, but it's erasing it because I'm not targeting, like, if I do this. This is TypeScript doing something that's not technically correct because they're not semantically the same JavaScript. Come to TC39 if you want to know why. Yeah, exactly. Exactly. Okay, let's do that. And let's just do a different example. It doesn't have class fields. Ignore the fact that it's added ustrict to the top. So here, like the code that's come out looks a lot like the code I've put in. But that TypeScript, the way it processes things, even if I write this in a really kind of weird way, you'll see that it's making up its own decisions about kind of where things end up. So here, I didn't have any spaces between my plus. It decided to add spaces. The reason this happens is because by the time you get to TypeScript's stage where it produces the string, it's completely forgotten about what you typed in. It just has the last syntax tree that popped out of the transformer. It could have remembered exactly where everything is. That would be referred to as like a concrete syntax tree. But TypeScript doesn't optimize for that. They don't. They just kind of want to produce output. A result of this means that even with simple things, your code is shuffling around. So because of that shuffling around, we actually need a second output out of TypeScript. Not just TypeScript, like any kind of TypeScript transformer, like using ESBuild, SWC, Babel. Because of that moving around, you also need a source map to pop out as well. Source maps look a bit like this. They are not designed to be human readable. If you stare at them for long enough, you start to recognize certain patterns, and you go, oh, that maps to this number. You know you've spent too much time in JavaScript tooling when you can start to decode these in your head. So actually, when we're running this thing, we're getting back 2 strings. We're getting back the output text, and we're also getting back this big JSON string. Again, online playgrounds these days are so good. You can drag a source map in. So this is Evan Wallace's, the author of ES Build, made a playground. You drag in a source map, and it will show you actually what the source map has. So source maps are great. In fact, Bloomberg recently, and Daniel here was involved, Bloomberg have pushed to make sure there's actually now a task group in TC39 to make sure the standard for source maps is really solid, and then to maybe push source maps forwards. So source maps are great. However, source maps, it's kind of a shame we need them because they do add overhead. They add overhead to produce. They add overhead when you have multiple tools all in series. Each produces source maps, so you need another tool to merge all your source maps together. And then when you run your code, so here, when you're debugging, you really need source maps. Why do you need source maps? Well, if I put a breakpoint on this line, I'm not actually putting a breakpoint on this line. We need to tell the JavaScript engine, actually put a break line on maybe line 7 or line 4, and also a particular column. You may also need source maps for things like code coverage, when you're running your code, and you want your unit tests to actually say which functions were covered or not. That's all happening because of source maps. But processing source maps, generating them, adds a lot of overhead. And what do we say at the beginning? When we're developing, we want things to be as fast as possible. We want to minimize our overheads. So on something slightly different to wrap up. So we were building, and our builds were a bit slower than we wanted them to be. So we profiled them, and the thing we noticed that was quite interesting is that the scanner and parsing phase was, so this is a particular project we had here at Bloomberg. It's like 250,000 lines of TypeScript. It's like a very big project. So the build was taking about 3 seconds, and half a second was the scanner and parser. But 2 seconds of that was all of this stuff, which I wasn't expecting. I was expecting it to be way more the parsing stage. Why was I expecting that? I was expecting that because at Bloomberg, we use a particular flavor of TypeScript we like to refer to as modern TypeScript. And that means we treat TypeScript as JavaScript plus types. So we want to be writing anything that has runtime semantics to be standard JavaScript. And then the only thing we're using TypeScript for is all the type annotations to document the code, to assert types about the code. And then we want that all to be just erased, because again, we're in the pre-Porffor days. They don't have runtime semantics. They can't be optimized. So that all gets erased. The consequence of this principle is that there are some things that we give up. We say no to, in particular, these 3 bits of TypeScript that date back to the early days of TypeScript. You don't have to use them all in combination, but it made the slide smaller. So you have namespaces. These days, you can just use modules. This stuff predates ECMAScript modules. Enums, we just use a object literal as const. And here, classes, we love classes. Don't get us. The class is fine. The issue is the keyword here. Adding, so this is a constructor parameter property. Adding a public, protected, private, or read-only here means you're actually adding a field and an initializer. So that's actually expanding out to 3 lines of code. So we say we're not going to use those features. We'll just write the equivalent JavaScript. So coming back to this, why was I surprised? Well, I was surprised because we're not doing any transforms. We don't really need any information from the binder. We're just deleting the type annotations. So it's a real shame that we're spending the majority of our time doing a bunch of these things that surely we're not getting any benefit from. So we solved this with a library called TS_Blankspace, which we open sourced 2 weeks ago. So after this talk, you'll be able to go online, check it out. TS_Blankspace, what does it look like? Well, at the top of the file, it exports a very simple API that, unlike Porffor, which is very complex, really impressive, the thing about TS_Blankspace is that it's super simple. It has 2 APIs. One is you give it a string of TypeScript, it gives you a string of JavaScript. That's just a wrapper around the main bulk of the thing, which is we're still going to use TypeScript, but we're going to use a different public API. They have another public API called create source file, which means parse this TypeScript and give us back the TypeScript AST. And then we use that. So we use the second one because we actually want access to the AST. So our tool does the parsing, uses the AST for some other things. But if you're not interested in that, you can just use the top one as a convenience. And you'll notice that you don't get back a source map. You just get back your JavaScript. And the reason it does that is because this is what it actually does. So we have that TypeScript AST. This is the TypeScript we've passed in. And then it walks that AST as quick as it can. And then every time it hits a place that's a type annotation, it remembers and it goes, OK, we started a type annotation here. That's at the 17th character of the string. And then, OK, we've now got to the end of the type annotation. That was at position 31. We keep going. OK, we hit another type annotation, go through. And at this stage, we've got to the end of the file, and we've marked all the points that aren't valid JavaScript. They need to be gotten rid of. And we're just storing this in a flat array of small integers, because JavaScript engines love flat arrays of small integers. This is very, very fast. So we now need to produce our JavaScript output. The circles there just represent a space, because it's very hard to see a space. So what we do is we literally do string.slice and say we want to slice from the beginning of the string up until position 17. Now we have a type annotation. We know the length of type annotation. So we say, OK, we just want white space of that size, and if there's any new lines. And then we come here and we say, OK, we now string.slice again. We want a bit of JavaScript. Put in some space. We now want some JavaScript, put in a space, and now we're finished. Let's just grab the rest of the string. Another thing that JavaScript engines really like doing is just putting strings together, because under the hood, there's optimizations for that. They're not creating whole brand new strings every time. They're using an optimization called ropes. You can look up about ropes. Makes this really fast. Engines love doing this. So if we remove the markers, this is what's actually happening. So we have a TypeScript in, and then kind of wonky looking JavaScript coming out. I'm not saying that is beautiful. What I'm saying is this is valid JavaScript. And you don't need to look at it. That's just what you give your JavaScript engine. It executes it. It's a machine. It doesn't care that it looks a bit ugly. The advantage you now have of doing this is that everything's in the same position. So there's no need to generate source maps. There's no need to tell your debugger to load a source map. Because if you want to put a breakpoint on line 5, the engine puts a breakpoint on line 5. If you have an exception thrown from a particular character, then it matches where it came from your original code. So this worked, and it was fast enough. So it was able to prototype this quite quickly. But me just building something in a few days isn't the type of thing Bloomberg then just ships to production. So the next kind of challenge was actually making sure this thing is good enough to go in our build tools where financial applications are going to be using it to do financial things. So we tested this by, in our building tool, it's quite common for us to make build tool changes. And the good thing about building in-house tools is we know every single user of our tools, they all work for this company. I have access to all of their GitHub repos. So we have tools that will clone every single project, build that project, and then tell us the outputs of it. So I set up a job that built every project. It's like thousands of projects using their current TypeScript transpile module and using blank space, and then ran the output through Prettier and was like, do they look exactly the same? And if they looked exactly the same, then we're like, we've done the same job semantically. I also did the same with, so if you check out the repo and you run the test will clone the TypeScript repo, and they'll run all of TypeScript's tests against their internal API blank space, and again, to confirm the output's the same. And I was pleased we did this because it did catch a few things that we had to fix. The first thing is arrow functions. So this is bad output for the people taking photos. If you're writing a type stripper, you don't want this to be your output. So blank space was given this string, and then it output that JavaScript. And wonky, we expect wonky, but it kind of looks like it did the right job. It removed all the type annotations. The problem here is that if we actually look at the JavaScript spec, which is such a great spec, the people that work on it have done a great job. It's a very, very good spec to read. There's this really important part here that says it's not valid for there to be a line terminator, which means like a new line, between the parameters and the arrow. But what do we have here? Here we have the end of the parameters, and then we have not one, but we have 2, 3 new lines before the arrow. Because the type annotation, Prettier said you got a bunch of things, and Prettier put it over a bunch of new lines. That's valid TypeScript. TypeScript just says you can't have a new line between the end of the return type and the arrow. So what TS blank space does is it has a little special case for this. If the return type goes across multiple lines, it doesn't actually blank it out. It's like TS blank space star asterisk. In this case, it takes the closing parenthesis, and then it moves it down to the end of the return type. So instead of being up there, it's down there. So blanking slightly, just with a little move. That solves that problem. The next problem we hit was there was some code like this that was using the old style of doing type assertions. Again, blank space was doing this. Wasn't quite right. This one's probably more obvious because that code in TypeScript is saying, I'm returning an object literal. This is JavaScript, which is an empty function that just returns undefined. This isn't an object. This is an empty block. The one thing I don't like about JavaScript is that we use curly braces for 2 very different things. I remember when I was a kid learning JavaScript, I found that very confusing. So again, here, the spec says the semantics are different of an arrow function depending on whether the first thing starts with a curly brace or not. The downside here is I couldn't find a good way to fix this. We've thought of a bunch of ways we could fix this with preserving the kind of blank space principle of not moving things around. All of them had downsides. And thinking about it, when we scanned our code, none of our developers were actually really, I think I found like 5 places where people were using this style. And that's because TypeScript back in 2015, in TypeScript 1.6, for people that were around using TypeScript back then, they introduced an alternative way of doing these things. You use as on the other side. They did it because the angle brackets clash with JSX and TSX. But also, I think this is easier to read. So the solution here is blank space. If you put this in, it will give you an error back. And the fix is to run ESLint. And they have a rule to say, switch all my things over to this. The last problem we had was everyone's favorite thing, ASI, automatic semicolon insertion. I'm sure everyone here uses semicolons, I'm sure. But for people out there that aren't putting semicolons in their JavaScript, they may write some TypeScript like this, where they have some code, no semicolon, then they have some type definition, and then something else below it. Blank space removed the type definition, but now it generated JavaScript like this. And here we have an ASI issue. This is now not two separate bits of JavaScript split by a type. This is a call. This is treating this like a function and calling it passing a string. So this is bad. This is different JavaScript to what we expected. So the fix here is that TS blank space, when it detects this is happening, I was so tempted to just say I don't support like people that don't put semicolons in their JavaScript, but I have a big heart. So I instead wrote up some code so that it detects when this is happening, and instead of just blanking everything out, so that you can't see them, but there's like a whole bunch of white spaces here. It uses semicolon instead of one of those spaces to preserve the correct JavaScript. So this means that, so we're still using TypeScript scanner and parser because they're really good. It's like really high quality. The team at TypeScript are constantly kind of working on these things, and they're constantly keeping it up to date as the language evolves. And then we replace the rest of their pipeline with TS blank space. And when we build that project, we can see that instead of the scanner and the parser being the small bit and everything else dominating, it completely flips it over. TS blank space was 66 milliseconds to actually strip out those like 250,000 lines. Because walking the AST and then just putting all those strings together, that was all stuff the JavaScript engine loved. It can do it really fast. So now, the only thing kind of slowing us down is the scanner and the parser. And we think half a second to do like 250,000 lines of code is like good enough for now, because this is just your cold build. Once you've done one build, we cache it on disk. The second time you do a build, it'll only build the things that have changed. So this is only when you clone a project and you're doing that first build. We think half a second is OK. But we also think maybe we can get that down. Like, if we can get the scanner and the TypeScript parser faster, that will get that down. It also speeds up things like your VS Code experience. So we were really happy with these results. If we stack this up, so we can see our previous transpile module approach is taking close to 3 seconds. Switching over to blank space dropped us down closer to like 700 milliseconds. And we noticed that we could have gone slightly faster if we'd used SWC or ESBuild, but we were in like the same type of benchmark. And we were faster than any of the WASM libraries that were there, which I wasn't expecting. But we also get the added benefit of, as we saw earlier, TS blank space works on the TypeScript AST. So if you want access to the AST, it has to do that anyway. One downside about ESBuild and SWC, they're really great. They didn't meet our use case, because our use case, we want access to the AST. There's a bunch of other analysis we need to do. And ESBuild doesn't expose an AST. SWC does, but it's just not an optimized part of their API. Taking Rust objects, serializing them, marshing them over to JavaScript really slows them down. So they would actually go slower in our particular use case. This is just running them direct without trying to access their ASTs. The other good thing about TS blank space for us is that it's tiny. The whole project is just 700 lines of TypeScript. So you could read it quite quickly. It only depends on TypeScript, that's it. So this means when TypeScript keep bringing out their new releases, we may have to make 0 changes to this library. We might have to make 1 or 2 line tweaks to the thing, but it's going to be really easy for us to maintain because of the approach it's taken. So that's the end of my talk. And technically, we're running over in terms of the time, but then I started a little late. Do I have a few minutes to? Thanks.
Hello. Is this on? Yeah, cool. All right, any questions? Thank you very much. Yes, one here.
Thank you for, it's a very clever idea. I like it, and implementation. So what about type checking? Is it possible to make it fast, or is it out of scope of this library?
Type checking is certainly out of the scope of this library. Though the project Rob mentioned earlier that Tizian's working on, isolated declarations, that's kind of our vision for making type checking faster. That's an approach of making the type checker run in parallel. The good thing about TS blank space for us is that type checking requires the TypeScript compiler to create all the ASTs. So again, it's a scenario where TypeScript already has to create the ASTs, so we can give those ASTs to blank space to do the work with. So we see these things kind of working in partnership because they're going to be able to share the same code base, share the same data structures. But blank space itself, its job is to be a super simple type stripper, not a checker. But we have ideas separately on how to make type checking quicker.
Yeah, and one super small follow-up question. Do you have a linter to forbid all these enums, public access in constructor and namespaces?
I missed the first part of the question. So it's about enums.
Yeah, so do you have
properties
linter which will forbid to have these free forbidden items in the
in like
code
VS
base?
Code and
Yeah.
so it's easy to kind of see that. And also I'll add that we like the idea of enum. And I think other people here at Bloomberg would quite like to see enum as something in JavaScript itself, rather than it being a TypeScript feature. And Ron Buckton on the TypeScript team, he has a like stage 0 kind of document of like what that could look like. What would enum look like if we actually added it to the language? And we think that'd be great because then that fits our model. You can use enum because it's part of the JavaScript standardized runtime.
Yeah, I'm asking because I've had the same problems with enums in TypeScript. I don't want to have it again.
Yeah, I meant Matt Hooker there. He's got a great article about enums in TypeScript.
Actually, do you have a linter that checks for this? That was the question.
Yes, sorry, I said yes, and then I quickly moved over to say, but yes, we have lint rules, and there are existing lint rules that can also check these things.
Inside library?
The lint rules aren't public, but I think there are alternative public ones. Well, there's a mic. I'm going to switch over.
Yeah, I think now it's, yeah. I have a question about like JSX. Does this support JSX? Because with JSX, like, I think the structure would change quite a lot because you get added like, a lot of like function calls and new lines and that kind of stuff.
So yes and no. All tools these days need to have a playground, so I wrote a playground. If you tell it to parse it as TSX, if I now write TSX here, you'll get TSX in the like JSX in the output. So it's as if you go to tsconfig and you set JSX factory preserve, then that's the same mode we're doing. So we accept TSX as input, but you'll get JSX as output. And then some other tool will need to process that. I did try and think about a way you could transform JSX without moving things around, but I don't think you can do it. I think you could do some trivial cases, but as soon as you have like spreads and more complex props, like as soon as you even just do like, oh, that's the read-only side. As soon as you have spread props, it blows up to quite a big thing.
So what do you actually do with this output, like the output on the right with the JSX still intact?
For that, we then process it. We then take the JSX and then we transform it. There are other transforms we do for other things as well. But yeah, JSX is one of those places where you do have to do a transform and you do need a source map.
Okay, thanks.
It's a great question.
I think we have time for one more question. There's one down here. Yeah, cool, thank you.
Really nice talk. I'm curious because it doesn't seem intuitive to me. 3 seconds is a lot of time for a developer. So do you actually do some metrics on developer productivity after making these changes in terms of how fast or how quickly or how much increase the time to market after these changes?
No is the short answer, in that we don't try and measure like productivity of developers. We do measure build times So we have like telemetry that's tracking how long builds are taking. And so if we're seeing that go up, we can kind of do something about it. But I don't have the charts to apart from that charts we saw of that one project of it coming down. I don't have a chart available to show like a particular team's like how much time they were spending building each day.
Gotcha. Thank you.
You need to get the XKCD of the my code's compiling with swords and things.
Yeah, the team complaining me like we used all the compile time to go and have like lunch.
All right.
Thanks everyone.
Thank you very much.